Welcome everyone. My name is Satyajit Sahu. So welcome all the participants. So today we'll be solving questions of strength of material and we'll be solving 60 questions. And the 60 questions will have orientation of your AE examination and AE examination, AEE and AE examination of TSPSC. But these questions are oriented in such a way that it will be helpful for you for all the examinations. Okay. So let us wait for the other participants to join in and then we will be starting the class. Okay. So I request all of you to pick your pen and paper. Yes. Good morning Raghavendra. Good morning Karthike. Yes. I'll request that all of you pick up pen and paper because it's a practice session. So I will give you some time to solve the questions. Yes. It will be better that you just not see the the screen and answer. I'll request you that you pick up the pen and calculator if required. Okay. And first of all, try to do without the calculator, but have a calculator for quick calculation. Yes. So welcome Kiran, welcome Raghavendra, welcome Karthike. Okay. A short introduction about myself. Okay. My name is Satyajit Sahu and these are my credentials. You can just go through them. Let us not waste any further time and go to the straight announcements. Some announcements I want to do. Yes. So as we know that the GATE exam is also nearing, so we have started this 500 plus expected questions for your GATE examinations. Now if you are appearing for any state public service commission examination, then also these questions will help you. So please do attend that. So today at 10:45 p.m. we will have this class of most expected questions. So today there will be questions from environmental engineering. So 10:45 today, please attend this session. And also we have this formula test series. Okay, this has been conducted on Thursday, Tuesday and Saturday. So today we have at 5 p.m. the formula test for your fluid mechanics. So these two classes will be there for today. Good morning Venkatesh, Isan, Ankit and Aftab, one call. Yes. So attend these classes also today. It will be helpful for your TSPSC, AE and GATE. Okay. So we have a mega workshop also coming up where the key prospects, we can say what are the options for you if you are appearing for GATE. That will be taken by Rakesh Talreja sir, who is very experienced in the domain of GATE and he has himself got a very good rank. Okay, and he has also studied from IISc, so he will be the we can say speaker for this particular session and he has guided so many students. So if you want to have a better understanding of the prospects and also want to clear some doubts, I request you attend this session. Okay, that will be on 18 December afternoon 12:30. Okay. Also we have this mega mock test happening for GATE. So I request all the serious candidates that they appear for this particular mega mock test, whose video solutions also will be available, and this is free of cost. It is available on the app. Okay. Also we have the GATE and ESE test series, subject by test and then full test also available. Okay, if you want to avail, you can avail that from the app. Now coming to the questions. So everybody is ready. Shall we start now? Everyone is ready for the session. Shall we start? Thank you, Rohan. Shall we start now? Yes? Okay, chalo. So as I requested, everyone please keep your pen and paper ready. So we'll be solving around 60 questions. Okay. So now we'll be solving around 60 questions from strength of material, and these questions will be helpful for you not only in the TSPSC, okay, but for all the examinations. These questions are common to what? For all the examinations. The formulas, the concepts which will revise will be helpful for all the examinations. Okay. So great. Everyone has come, so arrived. So let us start the question. The first question is unit of second moment of area. What is the unit of second moment of area? Please write in the comment section. I want to see that who answers first. And you can also have a count of how many questions you have solved correctly. The unit of second moment of inertia. I am seeing your comments. Okay, Kiran has answered B. Okay, B. What is second moment of inertia? It is nothing but the moment of area is nothing but the moment of inertia, right? The second moment of area is nothing but what? The moment of inertia. And moment of inertia has the unit of what? Dimension to the power 4. So mm to the power 4. Very good. Next question. Okay, the moment of inertia of the rectangular section shown in the figure. Okay, it is about its base. It is what? About the base. What is the moment of inertia of this rectangular figure about its base? About its base. Please answer. About its base. Okay, Chandan has answered C. Very good, very good. Yes. See, if you know the formula beforehand, very nice. If you don't know, so we know that about the centroidal axis it is what? BD cube by 12. And this distance will be how much? D by 2. So I can use what? Parallel axis theorem. So about this axis it will be BD cube by 12 plus the area into distance square. Distance square, D by 2 square, parallel axis theorem, right? So this gives me what? BD cube by 12, and this is how much? This is BD cube by 4. BD cube by 4 can be written as what? 3 BD cube by 12 gives me what? Gives me 4 BD cube by 12, and the final answer is what? BD cube by 3. So answer is C. Understood? Next question. Okay, for the simple support beam shown here, the magnitude of vertical reaction. Okay, here, tell me, what's the answer here? What's the answer for this reaction at B? What is the answer for the reaction at B? That very straightforward question. If this is P, remember this is what? This reaction will be P into, suppose this is A and B, this is PAB, PA by L, right? And this is what? PB by L. So what is the right answer? D. So this will be how much? This will be equal to, I can say, P is 30, A is 1 divided by what? Total length is 3, that is what? 10 kilonewton. See, the questions will be more, see, there will be some good questions also, but since you are preparing for, AEE exam, okay, so you have to understand that you should not solve lengthy questions. You have to be very sure that you don't solve lengthy questions. That is waste of time now. Some good questions also I have put, don't worry. But don't solve lengthy questions. Question will be straightforward, formula based. Next question, question number 4. The cantilever AB carries loadings as shown in the figure below. Which one is the correct SFD for the beam? Which one is the correct SFD for this beam? Draw the correct SFD diagram. Please draw and tell me the right answer. What's the right answer to this? Right answer to this. See, RA will be how much? 2 kilonewton. RA will be 2 kilonewton because this is 2 kilonewton. Yes. Yes. So if I draw the shear force diagram, what will happen? Here upward load of 2 kilonewton, right? Then there is no load in this portion. Then downward load of 2 kilonewton, right? And there is no load after that. So this becomes what? Simply A. Straightforward question. Right? Question number 5. Okay. Do you know the answer to this? If you don't know, I will tell you. Don't worry. Tell me. Okay. This is we can say, this is which I'm going to be. This is what? Overhanging beam, right? This is a overhanging beam. This is a overhanging beam. Yes. In this overhanging beam, this portion is given X and total length is given L. So what is the answer to this? Some people have remembered answer or they know it. Very good. If you know it very good, the answer is B. But I will explain. What is the condition given? The maximum bending moment is as small as possible. I'll explain this. So this is our overhanging beam. This is our overhanging beam, right? And these are the supports. The support. I can say here will support reaction. Okay. Suppose the distance between the supports is B. Suppose. Okay. And suppose this overhanging portion is A. This overhanging portion is A. So if you see the bending moment diagram, it will be something like this. Yes, the bending diagram will be something like this. And the bending moment here will be how much? Minus W A square by 2. Good morning. Okay. And the bending moment here will be how much? W B square minus 4A square divided by what? Divided by 8. Yes, so we can say this is the maximum possible bending moment and this is what? The maximum negative bending moment. Now, the condition is given what? The condition is that this is as less as possible. This is as less as possible. This is as less as possible when the maximum bending moment, the maximum positive bending moment is equal to what? The maximum negative bending moment numerically When numerically they are equal, then I get the maximum bending moment as less as possible. So if you see, this maximum one is how much? W b square minus 4a square by 8. Okay, and this is equal to how much? W a square by 2. And I told numerically means like the mod, right? Now what happens? This becomes 4. You bring this 4 here, W would get cancelled, and I get what? B square is equal to, when you take this 4a square, I get what? 8a square, or get what? B is equal to 2 root 2a. B is equal to 2 root 2a. Now see, B plus 2a is equal to total length, right? You see, B plus 2a is equal to total length L. Yes, in place of B, what I can write down? 2 root 2a, and this is 2a is equal to L, and I can say a is equal to L by 2 is 2, 2 root 2 will be 2.83. So it is what? 4.83. From here, what I get? I get a is equal to 0.207 L. Or I can say this is a, or I can say what? The overhanging portion is 0.207 L, right? The overhanging portion is 0.207 L, right? Yes. And here B by A is how much? This also sometimes they ask you, 2.83. It is how much? 2.83. Means what? What is B by A? The ratio of distance between the supports and the overhanging portion. This also sometimes they ask in the examination. So as per this X is that A, na, the overhanging portion. The X is that A, so X is equal to 0.207 L. Understood? Very good. Go to the next question. Okay. Is the shear force diagram is given, SFD is given, the total vertical downward loads is asked. Please find out the answer and tell me. The total vertical load is asked. Please answer the question and tell me. What is the answer? 3800. Very good. 3800. Yes. You see wherever there is drop in shear force. You see the drop in shear force. Okay. This is 800. Right. Again there is drop of shear force. This is how much? Tell me. Plus 800 to minus 1200. This is what? 2000. Yes. And then this is what? Again drop is 1000. So always see how much drops were there. So this is 800, this is 2000, and this is 1000, right? So this is 3800 Newton total. You see 2000, 1000 and 800. Straightforward question. Next question. Okay, answer this question. What's the answer to this? Answer is C. No shear force at any part of the beam. What is written? You see, when you have only bending moment acting like this, there is no force, na? There is no reaction force. You see, there will be a supported reaction here. Sorry, this is a moment reaction. This is a moment reaction, right? There is no force, na? There is no force, there will be no shear force. So answer is C. Next question. Okay, now answer this. It's similar to that, but the difference is there. What is written? The resultant bending moment at the midspan will be 0. See, at the midspan we got the bending moment how much? WB square minus 4A square by 8. Yes, this is the bending moment. Now this is 0 written, right? So this is 0. This is 0. This is 0 means what? I can say B square is equal to 4A square, or I can say B is equal to 2A, or I can say B by A is how much? B by A is 2 and A by B is how much? A by B is 0.5. A by B is 0.5. So A by B is 0.5. So here I wanted to tell some things. Here I wanted to tell some things which they can ask in the examination. You should remember. See, from this overhanging beam, they will ask you two types of question. They will ask you two types of question. What are the two types of question? The first thing is that bending moment at midspan is 0. Bending moment at midspan is 0. Okay? Bending moment at midspan is 0. When bending moment at midspan is 0, B is equal to 2A. B is equal to 2A. Remember this. Or I can say B by A is 2. Another question they can ask is what? The maximum positive bending moment is equal to maximum negative bending moment. Or I can say this is what? This is the maximum bending moment is as less as possible. Same language, as less as possible. So if they ask you this thing, then what is the condition I got? B is equal to 2 root 2A. You have to remember this thing. See, obviously I have derived also. You can derive in the examination, but to save time, you can remember better. I can say B by A is equal to how much? 2.83. Right? B by A is equal to 2 by 83. Again, here in this, what is A? The overhanging portion, how much we got? We got 207L, right? Remember? The overhanging portion, how much we got? 0.207, right? Here, how much will be the overhanging? Sorry, not here, sorry. Here we got, right? Here, in the earlier case, we got how much? 0.207L, right? Now, what is the overhanging portion here in this case? Tell me. When the bending moment at midspan is 0, tell me. What is the overhanging portion in terms of L? In terms of L. .25. Others? Others? Yeah, you see? See, B plus 2A. B plus 2A is equal to L, right? Yes, B plus 2A is equal to L. And B is itself 2A. So 4A is equal to L, or I can say what? A is equal to 0.25 L. Yes. And here B, how much we get? B will get how much? B will get 0.5 L, right? B will get 0.5 L. All these things you remember. And see, in place of A, they can write PQ or XY, something like that. So remember what is A. See, here we are remembering in terms of A and B. They might give some other things, right? What is A? A is the overhang portion, right? A is the overhang portion. And what is B? B is what? B is the distance between supports. B is what? B is distance between supports. Distance between supports. Understood? Understood? So now here in this case, what is B you are getting? When the maximum positive moment is equal to maximum negative moment, or I can say maximum bending moment is as less as possible. Tell me what is B in terms of L? What is B in terms of L? This will be, I can say, 2.83 into 0.207 L, right? How much is that? Tell me. 2.83 into 0.207. I am getting 0.585. Yes, it's almost what? 0.585. Yes, B is how much? 0.585 L. So all these things are directly asked to you in the examination. Directly they will ask you in the examination. And remember that when the bending moment at midspan is 0, B by A is equal to 2, A is equal to 0.25 L and B is equal to 0.5 L. Okay, standard results. The standard results were repeatedly asked in the examination. Similarly, for this condition, when maximum bending moment, positive bending moment is equal to maximum negative bending moment, or against the bending moment maximum is kept as low as possible, these are the things we should know. Understood this thing? So many objectives actually we covered in this one question, right? Yes. The next question, question number 9. For a linear isotropic material, elastic isotropic material, okay, what are the number of independent constants? What are the number of independent constants? Please be fast. We are going slow. We are going slow. Yes, it is 2. Modulus of elasticity and your Poissons ratio. Other things we can express in terms of these two. Okay. Now the bulk modulus of elasticity is given what? The bulk modulus is what? K is given what? Twice the modulus of rigidity. That means what? K is given 2 times of the rigidity. The Poissons ratio is asked. Right? So what you will do? Directly you can use this formula. What is the formula? Poissons ratio is 2K minus 3K minus 2G by 6K plus 2G. Okay. So what is the answer? Tell me. Direct formula, you should remember this formula. Direct formula, use this formula and this relationship given in this question. Use this relationship given in this formula. This formula should remember. All these formulas should remember. What is the answer? Tell me. Direct Poissons ratio. How much are getting this? For question number 10. Come on, fast, fast. Fast, fast, fast. Initially we were slow, now you have to be fast. B. Yes. C. In case of K, I can put 2G. So this becomes what? 6G and minus 2G. 6K becomes what? 12G plus 2G. So that is what? 4G by 14G. So 2 by 7. Yes. Straightforward question. Question number 11. The modulus of elasticity is given. E is given. Poissons ratio is given. The approximate value of what? Shear modulus. Shear modulus is G. So we can use this relation. E is equal to 2G 1 plus mu. See, calculator is not allowed, so better is to do without calculator. You can take this E as 190 na. You can find out approximate, right? You can take 190. 190 is equal to 2G and this is 1.3. This is 1.3. So I can say this will become 95. So 95 by 1.3. See, 95 by 1.3, the possible answer is A only na. Yes or no? Out of the given options, 95 by 1.3, the possible answer will be this only na. Yes, 73. You did not calculate always, okay? You can be little smart also sometimes, right? You can be little smart also sometimes because the other options are less than 95. Yes, are more than 95 or in the range of 95. So obviously it will be what? 73. Yes. Understood. Next question, question number 12. Direct formula also they ask you. They directly ask the formula between different relations, these different constants. So remember the first formula is what? E is equal to 2G 1 plus mu. Next formula is what? The next formula is E is equal to 3K 1 minus 2 mu. Yes. And if you combine both this formula, when you combine this, equate this to this, you will get this formula. Mu is equal to what? 3K minus 2G by 6K plus 2G. Yes. And another formula we get. Another formula get. What is the formula? E is equal to 9 kg by 3K plus G. Yes. So if you put this mu here, na, if you put this mu, you will get this relationship. Okay, you will get this relationship. Right? So these 4 relationships you should remember between the elastic constants. Sometimes directly they ask you in the answer. They might frame a question like this, or they might ask you directly formula also in the examination. Next question. Okay, the modulus of rigidity is given, the modulus of elasticity is given, the Poissons ratio is asked. Please answer this question as fast as possible. Please answer this question as fast as possible. Come on, fast. Come on, fast, fast. Come on, answer fast. Okay, very fast, very fast. Very fast. Okay. So see, very easy. 250 is equal to what? Is equal to 2G into 1 plus mu. So I can say 1 plus mu is equal to 1.25 or mu is equal to 0.25. Straightforward question. Fast. Next question. The Poissons ratio is asked. Poissons ratio is what? The lateral strain. Lateral by longitudinal strain. Okay, lateral by longitudinal strain. So if we have a bar like this, suppose we have a bar like this, if we have a bar like this, you see this is the longitudinal direction, right? And this is the lateral direction. So the lateral strain will be how much? It is direction of diameter, right? So I can say the change in diameter by original diameter, and you see the longitudinal direction is what? In direction of length. So strain will be the change in length by original length. So I can say the Poissons ratio, the strain ratio is will be what? Delta D by D divided by what? Your delta L by L. So this will become the formula for your Poisson's ratio. You see, this is the diameter, this is the D given, right? This is the length given. Okay, it elongates 0.15. That means what? This is your delta L, and diameter decreases by this. This means what? This is your delta D. Okay, so everything is given. Give me the ratio and answer, final answer to this. Question number 14. Tell me the right answer. What's the Poisson ratio here? Straightforward questions will be asked like this. If you are solving all these questions, there is very good chance that you will be able to solve question in any examination. So please attend these sessions. The questions are designed in such a way. See, all these questions you know. This is a practice session. So all the questions flow and everything is decided in such a way that all your concepts are revised. So you can get, I'm getting 1 by 3, that is what? 0.33. Just put the values. I am not solving. Okay. Just put the values. Very straightforward. Very good. Question number 15. Direct question. Tell me the right answer to this. Tell the right answer to this. Please answer. Come on fast. We have to increase our speed. We have to increase our speed. Which gets permanent deformation under load, which is not recovered after removal of load. Not recovered after removal of load. Plasticity. Plasticity. Yes, plasticity. Very good. Ductility is the ability to deform without fracture. Ductility is the ability to deform without fracture. Yes, when there is permanent deformation, that is what? Plasticity. Next question. The ability of the material to absorb strain energy till elastic point is what? Till elastic point is what? Tell me right answer. Come on fast. The ability of material to absorb strain energy till elastic point. Yes, it is resilience. It is resilience. And if I ask you till fracture point, what is the answer? Till fracture point, what is the answer? If I ask you till fracture point, what is the answer? It is not mentioned here. Toughness. Very good. Till fracture point, it is toughness. Very good. Question number 16 is over. 17. Come on, fast. You have to find out the elongation of bar. The elongation of bar is what? PL by AE. Right formula, PL by AE, right, of bars. So this is area. Area is how much? 400 mm square. And you see, this is length of the bar. So take in mm, because everything is written Newton mm. Okay. This is your load. Load you can take 40 × 10⁻³ Newton. And you see, this is GPA. See, E is given in GPA. You have to find in Newton mm square. So what will happen? This is 10⁻³ MPa. Or I can say this is what? This is your 2 × 10⁵ Newton per mm square. So put all these values. See, whenever they ask you find out this deformation in mm, na, put everything in Newton and mm. Put everything in Newton and mm, will get the answer. Please tell me the answer. What's the right answer? Okay. Fatafat, fatafat. Fatafat. Okay. B. Very good. Next question. The limiting values of Poisson's ratio are what? Means the range of Poisson's ratio is what? Tell me what is the range of Poisson's ratio. Come on fast. What's the range of Poisson's ratio? Yeah. These are for your TSPSC only. That is written in that heading, na? This is written in the heading, na? Yes. Answer is D. 0.5. 0.5. Okay, 0.5. Yes. Okay, match the following. Match it. Match the following. Different constants are given. Young's modulus is E. Poisson's ratio is mu. This is bulk modulus. Rigidity modulus is shear modulus, or G. Right? Please answer. It is written, na, TSPSC. Because वो गलत है. Cannot be -1. Because take the mod. So Poisson's ratio is mod. Okay. What's the answer to this? Okay, let us see. Let us see. Young's modulus is stress versus strain. Okay. Poisson's ratio is lateral strain to your linear or longitudinal strain. Bulk modulus is direct stress to volumetric strain, and rigidity modulus is shear stress to shear strain. So 2A, 1B, 2A, 3D and 4C. Answer is A. Okay. Next question. Question number 20. The ratio of Young's modulus. Again you see similar questions getting repeated. And G is given. E by G is given. You have to find out E by G when the Poissons ratio is given. Very straightforward. Find the answer. Find the answer to this. Very straightforward. Okay. What is the answer to this? A, yes, 2 into 1.2, right? 2 into 1.2. How? E by G will be 2 into 1 plus mu, na? Yes, straightforward question, 2.4. Next question, question number 21. The ratio of stresses produced due to suddenly applied and gradually applied loads on a bar is what? The ratio of stresses due to suddenly applied and gradually applied. The ratio is what? Answer this question. Very straightforward question. Very straightforward question. The ratio of stresses produced by what? Suddenly applied and gradually applied. What is the answer? Yes, the answer is D. Yes, the answer is D. Yes. Next question. Question number 21. This is from bending stress. This is from bending stress. Okay. A steel wire 20 mm diameter is given. It is bent into a circular shape of 10 meter radius. The modulus of elasticity is given. You have to find out the maximum bending stress. Now we use this equation, right? Bending stress by Y is equal to what? E by R. So when I take the maximum bending stress, I have to take the maximum Y also. Maximum Y also, right? You see E is given, the radius is also given. You see, this particular is bending like this. The radius is also given, right? The radius of the bend is also given. This is given as 10 meter. Okay, very good. Now how much Y max I will take? That depends on the cross section. You see, the steel wire is bent, right? You see the steel wire is bent like this. Yes, the steel wire is bent like this. So if you see the cross section, Y max means what? Maximum distance per neutral axis. So I can say maximum distance per neutral axis will be how much? The diameter by 2, na? Diameter by 2, na? Yes or no? Diameter by 2? Yes. So here put everything in kilogram and centimeter square. So the maximum bending stress will be equal to what? E is given 2 into 10 power 6. See, radius is what? Radius is radius of that arc. That is 10 meter. In centimeter it will be 10 into 100. And then Y max is how much? D by 2. So D is 20. So D by 2 will be 10 mm. In centimeter it will be 1 centimeter. So what's the right answer to this? Tell me. What's the right answer to this now? What's the right answer to this? Very straightforward question. The answer is B. Here the only catch is, remember, Y max. How to find out Y max? It will be like this. And sometimes what they do, they give a scale. Sometimes they give a scale. If it is a scale, then cross section will be what? Rectangular, na? See, if it is a scale kind of thing, the scale is bending, suppose. The scale is bending. The cross section will be rectangular, right? And I can say that this thickness will be T. So what will be your Y max? The Y max will be thickness by 2, na? Yes or no? The Y max will be thickness by 2, na? If they give a scale, the same question they will ask in a different way. They give a scale, then what happens? This Y max will be T by 2. Understood? Understood? Yes. Next question. Question number 23. Okay. Okay. First of all, a square beam is lying flat like this. Then it is rotated in such a way that diagonal becomes horizontal. Then what happens to it? Moment carrying capacity. Please answer. If you know the answer, you answer. Otherwise, I will tell the answer. The moment carrying capacity, the strength of beam, it depends on what? It depends on the Z, section modulus. Now, if you find the section modulus for this, what section modulus for this? The section modulus is, the section modulus of this what? It is, you see, A cube by 12. Yes. Or I can say BD cube by 12. So F4 by 12. F4 by 12. Yes. See, what is section modulus? Section modulus is I by Y max, right? So you see, if it is square, then this Y max will be how much? A by 2. It's A by 2. Yes. Okay, son, you know, you write the answer. Okay. I am wrong. Huh? I don't want to argue. You have great knowledge, so You're correct, huh? Very good. I don't want to go into that thing. Okay. Now, this is what? This is a by 2. So how much we get? A cube by 6. Yes. Now, this z will be how much? See, the I remains same. The I remains same when it comes to y max. When it comes to y max. When it comes to y max. Then this is what? This is what? This is your, you see, this is how much? This is how much? This is root 2a, na? Diagonal length. This is a, this is a, this will be root 2a. So this will be what? Root 2a by 2 giving how much? A by root 2. Right? This is a by root 2. So y max here is a by root 2. A by root 2. So what happens here, you see, here I will get, you see, a cube only, then 12 and root 2. So this will be what? This will be 6 into root 2 into root 2, right? So I'll get a cube by 6 root 2. Okay? A cube by 6 root 2. Okay? A cube by 6 root 2. Okay? Now, suppose this is Z1, this is Z2. So if I find out Z1 by Z2, how much you are getting? Z1 by Z2, how much you are getting? Z1 by Z2, I am getting, this is a cube by 6 and this is a cube by 6. Some problem is there. Let me check. And then root 2. Yes, correct. So a cube get cancelled. I get what? Z1 by Z2 is equal to root 2. Z1 by Z2 is equal to root 2. Now, here many people are thinking this is the right answer, but you have to analyze properly. What is written? When it goes from here to here. So, when it goes from here to here, first of all we got Z1 is equal to root 2 Z2. No problem is that. Okay. Now from here to here, it has decreased, right? It has decreased, right? Yes, it has decreased. Yes or no? It has decreased or not decreased? See, Z2 is equal to Z1 by root 2, na? So it has decreased. It has decreased. So it has decreased means what? I have to, what is the decrease? Decrease is Z1 minus Z2 compared with Z1 into 100. Yes. So this is Z1. Okay, or I can write down Z2 in terms of, wait, some mistake I am doing. First it was laid flat and then it was rotated, right? So we have gone from Z1 1 to 2 condition. When I'm going from 1 to 2 condition, there is decrease, right? There is decrease. But how much decrease, that matters, right? How much decrease? Okay. So Z1 is, I can write down root 2 Z2 minus Z2. Yes, you have to compare with Z1 only, na? To compare with Z1 only. It is also root 2 Z2. I am getting how much this one? How much are getting this value? %29.27%, right? I'm getting 29.27%. Are you getting the same? Okay. Yes. See, Isan, see, you are trying to be very smart. Okay, you know the answers, but here what is asked, I am asking that only. You initially gave A answer, that is wrong only. Okay. You just remember that thing, you are answered wrong only. Okay, so what is the use of, remembering that if you have answered wrong? Okay, the answer is this. Okay, because read the question properly, na? What is asked? You are not read, okay, and you are answering. Okay, read the question properly. What is asked? The decrease. So when you have gone from 1 to 2, the decrease will be what? Z1 minus Z2 divided by original 1 Z1. Okay, so don't jump when you see the question. You might be knowing the fact. But just don't jump into the question. Read the question carefully, and small mistakes like this will give you, cancel the marks. Okay, they are not asked, from here to here. See, if you see from 2 to 1, see, if it is from 2 to 1, then I can say Z1 minus Z2 by what? By your Z2 only, right? If it is from 2 to 1, then what? How much I will get? In that case, this will be what? This will be root 2 Z2. So how much I will get? I will get 41.4% increase, right? Yes, 41.4% increase. Yes. So remember this thing. I'll erase everything. Now you can remember that if you want to remember, if you want to remember, if you are going from here to here, there is what? Decrease of 29.27%. There is decrease of what? 29.27%. Now going from here to here, there is what? Increase of how much? Increase of 41.4%. Yes. And then when if it is asked, suppose this is one case, this is two case. So Z1 by Z2 is how much? Z1 by Z2 is √2. Right? Everybody got the conclusions and what to remember for the examination? Yes. But if such a question is asked, read the question carefully, that from where to where they have mentioned. Initially it was laid flat and then rotated in such a way that the diagonal is horizontal. Yes. So we are going from this case to this case. Then it is decrease, right? Understood this thing? These things have to be little careful. Okay. These things are little careful. You might be knowing the answer and you will jump. See, if you know the answer also, don't jump. Read the question carefully. You were knowing this. Okay. But read the question carefully. Very good. Answer is this. So you will see many direct questions also we are solving, and also solving some tricky questions also. And many people will think that we want new questions, and see, the new questions and little tough questions are asked in GATE only. Okay, some new questions, 30-40% new questions are asked in GATE. If you see your state, we will have first focus on here. That is a major problem with many students. Now you are in strength of material. Why you are thinking about environmental engineering? That different session will happen. So now you are in strength of material, focus on this. Don't worry about other. That is the major problem we face in our studies. When we are studying X, study X. Don't think about Y, Z. That you will think after X is complete. So after this class is complete, at the end of the class you tell, sir, environment. After the end of the class. Now don't think about anything else. Just think about the questions. Question number 24. Straightforward question. Please answer this question. The strength of beam A to beam B. Strength means what? Flexural strength can be compared with what? The section modulus, right? This ratio is asked. Both are simply supported. Same depth, but beam A has double the width that of beam B. Yes, double the width. And nothing is mentioned means what? They are rectangular. Rectangular means what? Z is how much? BD square by 6. Tell me right answer. Now. What is the answer? Very straightforward question. 2. See, A is 2 times the width. So it is 2B into D square by 6. And this is simply what? BD square by 6, because the width is doubled but the depth is kept same. So 2. See, straightforward question also will be asked like this. Question number 25. The strongest rectangular beam cut from a circular log has ratio of width and depth. This you might be knowing the answer. If you have a circular log and you are trying to carve out a rectangular beam out of it. Okay, if you are trying to carve out a rectangular beam out of it, yes, you are trying to carve out a rectangular beam out of it, then what happens in this case? In this case, I can say that the width, this is the width of that particular beam, and this is the depth of that particular beam, and this is the strongest one. Let me make it small b and small d, and this will be diameter capital D. So from here I can write down small b square plus small d square is equal to capital D square. Yes, and then from here I can tell that your d square will be how much? Capital D square minus b square. Now when I say the Z of this beam, that will decide. The answer is actually D only. Yes, correct, good. But let us just derive it if you have some time. You see, so Z, sometimes we get confused. So if you know the derivation, we don't get confused. So Z is equal to what? Z is equal to BD square by 6. Z is equal to BD square by 6. Yes, for a rectangular section. So in place of D square, I can write down what? Capital D square minus small b square divided by 6. And that will give me what? BD square minus b cube by 6. Right? Now for your Z to be maximum, strongest section means what? Strongest section means Z will be maximum. For Z to be maximum, what will happen? For Z to be maximum, I can say that this dz by dB will be equal to 0. So for differentiate with respect to B, what will happen? First term will be d square, second term will be what? 3b square, and this will be equal to 0. I can say B will be equal to d by root 3. And what will be the depth? Depth square was what? The diameter square minus b square. So I can write down d square by 3 minus 3. This is d square only. This is d square, and this is what? D square by 3. So giving me what? 2d square by 3, or I can say this depth will be root under 2 by 3 capital D. So when you take the ratio of what? Width to depth, I'll get what? You see, I get 1 by root 2 now. I get 1 by root 2. So this is how much? 0.707. Okay. Next question, 26th question. Okay, shear stress distribution. Come on, little fast. We are going little slow. Shear stress distribution, which is this? This is the shear stress distribution given. Now this belongs to which beam, which cross section? This shear stress distribution belongs to which cross section? This belongs to which cross section? You see what has happened? It was going parabolic, then it decreased. The sudden drop is there. Then parabolic, sudden increase. See, whenever there is sudden drop or sudden increase, that means the cross section has changed, right? The cross section has changed because the shear stress is inversely proportional to the width. If other parameters are same, shear stress is inversely proportional to width. So if the shear stress has increased, that means what? Width has decreased. If the shear stress has decreased, that means what? Width has increased. You see, this is the right answer. A is the right answer. Why? Because you see here at this junction, at this point, what has happened? The width has increased, and therefore the shear stress dropped here. You see, shear stress dropped, and here we can say what happened? The width decreased, and therefore there is increase in the shear stress. So answer is A. Next question, question number 27 from torsion. A shaft turns at 150 rpm, okay, with a torque of this. The power transmitted in kilowatt. The power transmitted in kilowatt is equal to 2 pi nt by 60,000, where this T is in Newton meter and this is in rpm. So what's the right answer? Tell me direct formula. Direct formula, tell me. See, in the examination, most of the questions will be direct formula only. Most of the questions will be direct formula. It is now up to you that how you are covering the syllabus. So therefore, focus now on coverage of syllabus. Don't go into great depth. So answer is what for this? See the expression in terms of pi. So 2 n is 150 and this is 1500 pi and this is 60,000. No calculator is required. This is I can say 40. 7.5 pi. 7.5 pi. Okay, let me switch on the AC. It will be a little hot. So 7.5, this right answer. Next question, 28th question. It's a solid shaft, diameter is given, subject to a torsion. The maximum shear stress. The maximum shear stress in case of torsion for a solid shaft is how much? It is 16T by pi d cube. 16T by pi d cube. Now when you're finding the answer in Newton per mm square, everything you should put in Newton and mm. 16, the torque is kilonewton meter. So convert into what? Into per 6 Newton mm. And then pi d cube. D is how much? 80 and this is cube. Okay, so mm cube. Now it is expressed in 1 by pi. It is expressed in what? Is expressed in 1 by pi. There is no need to what? Find in what? This solve this pi. Now this question you can solve easily. 16 into you can say into per 6. This will give you pi. So 8 cube is what? 8 square into 8. So that is 64 into 8, right? And into per 3 then, right? So this get cancelled into per 3 again. Now this is 4, right? This is I can say 250. I have done some mistake. Oh, this is I forgot this t value. T is also 4, na? Yeah. So this is 2. So 125 by pi, right? Yes, 125 by pi, right answer. See, you can solve the questions without calculator also. Don't worry. Don't open the calculator always. Okay, question number 29. Okay, the shear stress distribution in a triangular section is maximum where? In a triangular section, where we get the maximum shear stress? Tell me, direct question. Where we get the maximum shear stress due to shear force? Obviously, nothing is mentioned. At what height we get? At what height we get? We get at mid depth. Very good. The shear stress is maximum at the mid depth of a rectangular section. So suppose this rectangular section like this. The original distribution is parabolic only. Okay, and this is the maximum shear stress, and this is at h by 2. This is at h by 2 only from top and bottom. And this is how much actually? This is how much? This is 3 by 2 times of average. And the neutral axis is at h by 3. Neutral axis at h by 3. Here how much we get? Here we get this is equal to 4 by 3 of average. And 4 by 3 is less than 3 by 2, na? Yes. See, 4 by 3 is less than 3 by 2, na? This is 1.33 of average, and this is how much? This is 1.5. From diagram also it is understandable. Understood? So we get the maximum here. We don't get at the neutral axis. Understood? Question number 29. Okay. This is from shear stress only. You see this P point is just above the junction. Yes. And this Q point is just below the junction. Yes. And it is given that at this junction at P, it is 12 megapascal. What will be the shear stress at this Q? Tell me. What's the answer to this? I told you, right? Shear stress is inversely proportional to B width. And the other parameters are same. The same process, other parameters will be same. So what's the right answer to this? Tell me. See, we revised 30 questions in less than 1 hour, right? And so different concepts, different formulas. So please do attend these sessions. B60, great. B60, yes. You see, can I say the shear stress at P by shear stress at Q will be equal to the width at Q divided by width at P, right? Because inversely related. So width at Q is how much? Width at Q will be 20, na? Yes, because the Q is in the wave. And width at P will be how much? 100, na? Because that is in the flange. So by 5. So I can say your stress in Q will be how much? It will be equal to 5 times of stress in P. That is how much? 12 into 5 is 60. Understood everybody this question? Straightforward question. Okay. Next question, question 31. We have a hollow shaft with an external and internal diameter as this much. What is the torsional section modulus? What is this torsional section modulus? This is also the polar section modulus, right? This is also the polar section modulus. Now polar sectional modulus is what? It is J by R max. It is J by R max. Okay, J by R max. Now suppose we have a hollow shaft like this. Yes, you have a hollow shaft like this. Yes. So R max will be how much? This R max will be equal to the external one divided by 2, na? Yes. Yes, this R max, see this is hollow, but R max will be external one divided by 2. Now, what is the J? J is how much? It is pi by 32. Okay, for a hollow one it is how much? D naught to the power 4 minus di to the power 4. Yes. Now this divided by R max is how much? D naught by 2. So I get this formula how much? Pi by 16, right? D naught to the power 4 means what? D naught is how much? External is given 10. 10 to the power 4 minus 5 to the power 4 divided by what? 10 by 2 is equal to what? 5. Yes. Now this can be written as, see, pi by 80. See, this can be written as 10 square minus 5 square. 10 square minus 5 square into 10 square plus 5 square, right? And this I can write down as how much? This can write down 100 minus 25, 75. And this is 100 plus 25. That is what? 125. Now you can solve this, right? You can solve this and give me the approximate answer. Okay, so solve this. What is the answer to this? What is the torsional section modulus of this? Tell me. What's the answer? See, for a solid one, this is simply what? Pi by 16 d cube, right? For solid one, this is added formula, but this is asked for what? This is for hollow. So how much you are getting this answer? Tell me. See, you are getting, huh? How? I have done some mistake, huh? Let me see. Some mistake I have done. Let me see. Everyone is getting C only, huh? J is pi by 32, no? Yeah, J is pi by 32 only, right? Yeah, we are getting 368. Okay, centimeter cube, because everything I have expected is centimeter. Next question, 32 question. You have to go fast or go slow. If the strain energy is stored in a unit volume of shaft, the strain energy per unit volume in a hollow shaft is given this much: 17 maximum shear stress square divided by 64 G. Now what is this? Is 17 maximum shear stress square, I can write down, divided by 64 G. Now what is the general formula for strain energy per unit volume? This is tau max square by 4G. This is for what? This is for a solid shaft. For a I can say hollow, it is d naught square plus di square divided by what? Your d naught square. Now this is given as how much? This value. Yes, this is given as this value. Now can you give me, this will be what? This I can say will be 1 plus di by d naught square, right? So now can you give me this value? Tell me. From this, compare these two, and can you give me what is di by d naught? Tell me what's the right answer. This is for a hollow. This is for a hollow. For solid it is how much? Only tau max square by 4G, which is the strain energy per unit volume. Give me the answer to this. What is the value you are getting here? Equate these two. Equate these two. So when you equate these two, what will happen? When you equate these two, what will happen? Arey, what took you so much time? 17 by Hey, we're getting 1 by 4 na? So much time you're taking. Understood? Straightforward question. Remember the formulas. Okay. Per unit volume, the strain energy is by 4G. This is for what? This is for torsion cases. And this is for solid one. For hollow one, I have given the formula. I'm not writing again. 33 question. Okay. What is written? The maximum shear stress developed on a solid circular shaft under pure tension is 320. If the shaft diameter is doubled, then what will be the maximum shear stress corresponding to same torque? Straightforward question. The maximum shear stress for a solid one is how much? It is 16T by pi d cube. Now if torsion is same, I can say tau max is what? It is inversely proportional to 1 by d cube. Yes, or I can say the shear stress 1 by shear stress 2 will be what? Your d2 by d1 whole cube. Right? Reverse order. So the d1 tau 1 is given 320. This is, and d2 is given how much? it is doubled. That means what? Becomes 2d1, right? 2d1 by d1 whole cube. This becomes what? 8, right? This is 40. The shear stress is how much? The maximum shear stress is 40. Again you see straight formula. Next question, 34 question. Okay. Now something from what? From your principal stresses. Something from principal stresses. It is observed that the minimum principal stress on a certain plane is 0. Means what? The sigma 2 is 0. When sigma 2 is 0, then what is the condition? You should remember this. What is the answer to this? When sigma 2 is 0, which of the following condition is valid? See, sigma 2 is 0 means what? The circle is, the center will be called radius, because you see sigma 1 is center plus radius and sigma 2 is what? It is center minus radius. So when I say that 0 means what? C is equal to R. So C is what? Sigma x plus sigma y by 2, and I can say if I take a square, this whole square, and radius square will be how much? Sigma x minus sigma y by 2 whole square plus your tau xy square. Now if you take, open the brackets, what will happen? Sigma x square plus sigma y square, okay, plus 2 sigma x sigma y. Okay, I will take this as 4 and divide by 4. So this will be, all the 4 will be getting cancelled. So this will be equal to sigma x square plus sigma y square minus 2 sigma x sigma y plus your tau xy square. 4, because you see denominator everywhere it is 4, 2 square and 4, right? So that everything got cancelled. So from what happened, this will get cancelled, this goes this side, this becomes what? 4 sigma x sigma y. Now this is equal to this, 4 get cancelled, I get what? Tau xy square is equal to sigma x sigma y. So I get this relationship. Yes, question number 34. Let us go to the next question, question number 35. What is the maximum shearing strain? You see the maximum, what is the formula? The maximum shearing strain is nothing but the radius of the mode circle for strain. So radius, is this correct? No, by 2, right? This is the formula, right? See, maximum shear stress is radius of what? Of the mode circle. Maximum shear stress is radius of mode circle, but maximum shear strain is not radius of mode circle. Maximum shear strain by 2 is the radius of mode circle. So I can say from here, this by 2 is equal to radius. Radius will be how much? Root under epsilon x minus epsilon y by 2 whole square plus your gamma xy by 2 whole square, right? Yes. Now this becomes equal to what? Just take this 10 to the power 6 common. 10 to the power 6 common you can take outside of the bracket. 10 to the power minus 6 common is common. So this will be 800 minus 400 by 2, 200 square. 200 square, and this will be 300 by 2, 150 square, right? So this gives me how much? You see, 200 will give me what? 4000 plus 22500. That means what? 625000. Yes, that means what? I get 250 na? I get 250 to minus 6. But this is not the right answer, because this is what? This is maximum shear strain divided by 2. So maximum shear strain, how much we get? Maximum shear strain, how much we get? We get the maximum shear strain as 500 10 to the power 6 minus 6. Yes, the answer is what? D. Under 21. Next question, question number 36. Tell me, the mode circle given corresponds to which one of the following stress condition? I am not able to see the answers coming fast. You have all become lazy, or you are not studying. You are not studying. Many people, I think, are not studying at all. Why I am not getting the answers? What is the answer to this question? It is pure shear, but answer the question. Which option? It is pure shear condition. Which answer? What is the right answer to this? What is the right answer to this? Yes, it is C, because you see pure shear condition, shear stress is 1000. In this case, what happens? Sigma x is 0, sigma y is 0. So what happens? Center is equal to 0 and radius becomes equal to what? The shear stress. So center is 0 and the radius is what? Equal to the shear stress. Yes, this is what? Your pure shear condition. Next question. Question number 37. Okay. See, all these questions are designed in such a way for your state exams, and also this will be gate 1 mark questions, and this also will be the ESE straightforward questions also. Okay, the plane carrying maximum shear stress. Answer this question. The plane carrying maximum shear stress. The plane carrying maximum shear stress. It is 45-degree inclined to principal planes. Yes, the maximum shear planes are 45-degree inclined to this. Straightforward. Yes. So I can say maximum shear plane 45-degree to your principal planes. Now what is the angle between principal planes? What is the angle between principal planes? What is the answer to this? What is the angle between principal planes? What is the angle between principal planes? 90 degree, correct. Question 38. Straightforward theoretical question. The maximum principal stress theory corresponds to which failure theory? What is the name given? Now these things are asked in your state service examination a lot, so please answer this question. The maximum principal stress theory is also known as which theory? It's also known as which theory? The maximum principal stress failure theory is also known as what? Which theory? It is Rankine theory. It is Rankine theory. Question 39. The maximum shear stress theory. That was principal stress. That was principal stress. This is maximum shear stress. The maximum shear stress theory is corresponding to which theory? Name. These names are also asked in, okay, sometimes in ESE also they have asked this thing. Get less chance. They will be mostly asking this in this. What's the answer? Tresca is the right answer. Question number 40. Maximum strain energy theory for the failure. Strain energy. This will be little tough. Let us see. The maximum strain energy, little tough. Tell me, what's the answer to this? Saint-Venant? Yeah, it's Haig's theory. Saint-Venant is maximum principal strain theory. The Saint-Venant is what? Maximum principal strain. Now there is another theory. That is what? Your maximum distortion energy. Or I can say maximum shear strain energy. Maximum distortion energy, you can say what? Maximum shear strain energy. And that is name is von Mises. That is what? Von Mises. That particular name is what? Von Mises. The names are asked in the state exams, you should be knowing them. Okay, the names will be asked in the state exam, you should be knowing them. Von Mises. Next question. Okay, the equivalent bending moment when we have a bending moment of M and T. What's the right answer? Straightforward question. Remember this, straightforward question. M equivalent when we have a bending moment and torsion acting together. What's the right answer? Read the options carefully. Yes, it is D. It is M plus root under M square plus T square divided by 2. And the equivalent torsional moment is what? It is simply M square plus T square. Right? They can form numerical also, right? If they give you the M is equal to 6 and T is equal to 8, can I say the equivalent moment will be 10? Na? The equivalent torsional moment will be 10. Yes, and I can say the equivalent bending moment will be 10 plus 6, 8, na? Yes or no? The equivalent bending moment will be how much? Let me see. 10 plus 6, 8, na? Yes or no? Understood? Yes. Such kind of question they can ask, you should know. 42nd question will go to Kern zone. A short column with an external diameter of D1, okay, and internal diameter of D2 carries an external load W. For no tension condition, the eccentricity will be how much? Okay. If you know the answer, very good. If you don't know the answer, I'll explain to you. See, circle. It's a hollow circle. Suppose it's hollow. Okay, hollow. It's a hollow. Okay, it's a hollow. Okay. Now it's a hollow circle. It's a hollow circle. Okay. Now when I say the eccentricity, now what's the formula for stress? The stress will be P by A minus moment by Z, right? Or I can say PE by Z. Now no tension means what? No tension means P by A should be greater than equal to what? PE by Z, right? Or I can say that, get cancelled, eccentricity will be within what? Z by A, right? If this is the eccentricity Z by A, remember Z by A, then I can say there will be no tension. Now if I say for a, let us go to first circle. Suppose it's only a circle. It's only a circle. Then E will be how much, tell me? If it is only a circle, then what I can say? E will be how much? Z is what? Pi by 32 d cube now for a circle. Pi by 64 d to the power 4 by d by 2, right? And divided by area will be how much? Pi by 4 d square. So here I will get how much? I will get d by 8 only, right? I'll get d by 8 only if it's a circle. Now we are considering what? We are considering a hollow circle like this. Then what will happen? E will be equal to Z. Z is what? Z is I by Y max, right? So I is how much? I is pi by 64. Then external diameter to the power 4 minus internal diameter to the power 4. Yes, this is I by Y max will be how much? External diameter divided by 2. And then area will be how much? Pi by 4 into external square minus internal square. Yes. So what will happen here, you see, if you solve this, pi get cancelled, this becomes 16 and this becomes 8, right? So what I get, you see here, this can be written as d1 square minus d2 square, and then what? d1 square plus d2 square. Yes, you did put by 4 term and divided by what? I can say d1 square minus d2 square. Okay, then we have a 8 d1 term here. So this get cancelled. I get what? d1 square plus d2 square by 8 d1. Understood? Remember, if you are forgetting the formula, remember only one thing. Eccentricity is what? Less than equal to Z by A. Yes, for no tension condition. And I can say for rectangle, what will be the condition? For rectangle, eccentricity will be how much? Z will be what? Z will be BD cube by 12. Z will be what? BD cube by BD square by 6. BD square by 6, and area is BD. Area is BD. So I can say what? It is D by 6. Yes, for rectangle it is what? D by 6. Yes, eccentricity will be what? D by 6. Okay, okay. D by 6 in one side. On the other side it will be B by 6. D by 6 on one side, other side will be B by 6. Understood? Okay. Next question. Question number 43. We have a thin cylindrical cell. The ratio of the longitudinal stress to the hoop stress. In a thin cylindrical cell, remember that the hoop stress is how much? Hoop stress is PD by 2T, where T is the thickness, and D is what? D is the diameter. D is what? D is the diameter. And what is the longitudinal stress? Longitudinal stress is what? PD by 40. PD by 40, half of it. So they have asked what? Longitudinal by hoop. That is half. Remember this. Longitudinal by hoop is what? It is half. Okay. Understood? Very good. So answer is this. 44th question. The radial stress in a thin spherical pressure vessel. What is the answer? The radial stress in a thin spherical pressure vessel. What is the answer to this? The radial stress. The radial stress is how much? The answer to this is how much? 0. Yes. See, in thin it is 0. Thin it is 0. In thick we will have what? We will have a non-zero. The expressions I am not discussing here. We will have radial stress as non-zero. But for thin cylinders and spheres, the radial stress is 0. Remember this fact. Okay. Next question, 45th question. Okay. So we have a cylindrical cell. Okay, cylindrical is there. Very good. The maximum shear stress is asked. Very easy, right? You see, this hoop stress is the sigma 1 actually, the major principal stress PD by 2T. Okay, the longitudinal one is the minor one, that is PD by 4T. So what will be the maximum shear stress? The maximum shear stress is difference of the principal stresses divided by 2 na. Yes, so I can say PD by 2T minus PD by 4T. It is PD by 4T divided by 2 giving what? PD by 8T. For cylinder I'll get this. For cylinder I'll get this. Now tell me, what's the answer to this? What's the answer to this? Tell me. We put the values. 1.5 into diameter is 1000 and then thickness is 15. And 8 is there. So 100 by 8. 12.5 Newton per mm square. Yes, 12.5 Newton per mm square. Everybody got this? Everybody got 12.5 Newton per mm square? Yes. Now this is for a cylindrical thing. This is for a cylinder, thin cylinder. For thin sphere what will happen? For thin sphere what will happen? Remember, for thin sphere what happens? The hoop stress and longitudinal stress is same. That is how much? PD by 40 only. The hoop stress and longitudinal stress is same. That means what? The maximum shear stress is 0 here, right? Here it will be 0 na. Understood? Understood this thing? Should know. Next question. 46th question from columns. So from columns, okay. So the buckling load expression is given, and then you see for different conditions, you know, A, B, C, D things are given. So what is that which is not correctly matched? Answer this question. Straightforward question. We know that the buckling load is what? The buckling load is pi square E I by L effective square, or I can say K into L square. Okay, what's the right answer? Which is not rightly matched? Which is not rightly matched? Which is not rightly matched? Yes, this is not rightly matched. You see here K is equal to 1, so correct. Fixed means what? K is equal to 0.5, or I can say 1 by 2. So 1 by 2 means what? 1 by 2. Okay, this K square also. 1 by 2 means what? 1 by 2 means what? 1 by 2 square, so 4. Okay, 4. This is correct. Then here it is what? Here K is equal to 2 only. Fixed free. K is equal to 2. K is equal to 2. Yes. So K is equal to 2 means what? Here it become 4. Now divide by 4. Divide by 4 is how much? Divide by 4 is how much? 0.25, right? 2.2. This is also correct. Here K is equal to root 2. So when you do a square, sorry, 1 by root 2, sorry, it is 1 by root 2. So when you do a square, we get actually answer should be what? 2 pi EI by L square. Yes or no? This would have been the right answer. Yes. So this is wrongly matched. This is the right answer. 47th question. Okay, from springs. The equivalent spring stiffness. Very straightforward. You see these two are in series. When in series, how we find out the equivalent K? I can say the K equivalent will be 1 by 10 plus 1 by 40. I can say this K will be equal to 400 by 50. That is how much? 8. So these two will form what? Equivalent of 8 kilonewton per meter. Now these three are what? These three are in parallel. So we'll add them up. So 20 plus 30 plus 8, how much? 58. Straightforward questions. Question number 48. Okay. Now this question is from where? This question is from closely coiled spring. Closely coiled helical springs. So stiffness of the spring is asked. Remember the formula. The formula for the stiffness is G, shear modulus. The wire diameter to the power 4 divided by what? 64 R cube N. What is this? I'll just explain to this. Suppose this is a closed helical, spring like this. So this wire will have some diameter, na? This diameter is small d. Now this whole spring will have some radius. This is your R. And the number N is what? Number of coils. Yes. So if you want to express the stiffness in what? In N by meter, Newton per meter. So what I will do? I'll put everything in Newton mm, right? So this will be equal to G is how much? 8.4 into power 4 Newton per mm squared. D is how much? It is given 10 mm. So 10 to the power 4. 10 to the power 4 divided by 64. What is R? R is given how much? The R is given as 100 mm mean diameter. If this is the diameter, then R will be how much? R will be 50 mm, right? It will be 50 mm. So 50 cube. And number of turns is given how much? Number of turns is given 20. So what's the right answer you're getting here? What is the K value you are getting? Tell me. What is the K value you are getting from here? Yes, if you solve, you will be getting 5.25. 5.25 you will get exactly. Getting 5.25. But also getting the same value? Please answer in the comment section. Yes, you will get 5.25. In this formula, you should remember, you should know the terms. You should know the terms. From diagram, it is clear now. Next question. Okay. Now, the ratio of the deflection of two springs is asked. Now, first of all, this stiffness is GD4 by what? 64 R cube N. So, when I find out deflection is what? Deflection is load by stiffness, na? Or I can say load is what? Force is equal to, force or load is equal to what? K into the deformation in a spring. Okay, that be formula we know, Kx, right? Deform spring. So from here I can say deformation will be what? The load W divided by K. So here you see load is W, K is what? K is this. So I can put this expression GD4. The 64 will go up. So 64 W is there, R cube into N. So this is what? The deformation equation. You should remember this. Now they have written that two coils A and B are everything same. Just what's the difference? A has half the number of turns as that of B, right? Now you see, if every other parameter is same, can I say delta 1 by delta 2 will be what? It will be N1 by N2, right? So if the number of turns is half, this ratio is suppose half, or I can say number of Na by Nb is what? Na by Mb is half. So the deformation ratio will be also what? It will also be half, na? So answer is what? Half. Understood this question? Very easy question, but you should know. See here, they changed only the number of turns. If they change the diameter of the coil and the diameter of the whole helix, right? So I can say that delta 1 by delta 2. If the load is same, can I say it will be R1 by R2 whole cube into what? Into D2 by D1 to the power 4 and then N1 by N2, right? If you see that diameter of the coil is different and of the helix is different, then you will get this relation. They might ask a question on this, right? They will change the diameter and all. Okay. Next question. Question number 50. A 40 centimeter circular timber column is 4 meter long. Okay. What is the slenderness ratio? What is slenderness ratio, by the way? What is slenderness ratio? Slenderness ratio is the L effective by R minimum. Right? R minimum. Now nothing is mentioned about support condition, then what you can assume? You can assume both as, or you can assume this as what? The effective length only. So I can say this is your effective length, 4000 mm is the effective length, 4000. Now R minimum, what is R minimum? R minimum is I minimum by area. Now for circular section, I is same in all directions. So I can say this will be what? Root under I will be pi by 64 d to the power 4 divided by what? Area will be pi by 4 d square. So I can say this pi get cancelled, this becomes 16 and this becomes d square. So if you take a square root, it will be what? It will be simply d by 4. So you can put here what? D by 4. Very straightforward formula based question. So 4000 divided by what? D by 4 will be 10. So I am getting how much? I am getting 40. Okay, see this, they are asked in centimeter. Okay, sorry, this is okay. D is in centimeter. That is in. I will explain this in centimeter only. Centimeter only. So 400 only. So 400 centimeters. Sorry. This becomes how much? Becomes 40. Understood? Straightforward question, but you should know these basic formulas. Next question is 51st question. 10 questions to go. 10 questions to go. Let us be fast. We have a mild steel, 4 meter long. The flexural rigidity means what? EI is given, right? And both ends are hinged. When both ends are hinged means what? Your L effective will be equal to L only. That is how much? 4 meter. The crippling load means what? Buckling load. So buckling load is asked in what? Kilonewton. So what I will do? Buckling load is what? Formula is what? Pi square EI by L effective square. So you see pi is pi square. Now see, if you are solving this question, you don't have calculator, pi square always you can take as how much? Pi square you can take as your 10. It's almost approximately 10. You can take 10 for easy calculation. EI is what? 1.2 10 to the power 10 Newton mm square. Now you can express this in mm, right? This length is in mm, so 4000 mm I can express. So 4 square 10 to the power 3 square, so 10 to the power 6, right? Mm square. So this mm square get cancelled. The answer is asked in kilonewton. I am getting in Newton, so I will divide by 10 to the power 3 to convert into your Newton. Kilonewton, sorry. So this 10 to the power 9, so I get a 10 here. Okay. So this will be how much? 1.2 into 100 divided by 16. Yes. Or I can say 120. I can say 120 by what? 16. Or I can say if I divide by 4, 30 by 4. What is the answer? Answer is 7.5. But I have taken pi square approximately, so it will be little less than that. So answer is what? 7.4. So you see, you can solve these questions without calculator also if you do some approximations. Okay, you can solve without calculator also if you do some approximations. Next questions. 52nd question. Okay, with one end fixed and other end free. Okay, this is the column 1. Column 1 is what? One end fixed, other free means what? Pi square EI by 2L whole square, na? So 4L square. And second one is what? Second one is when fixed at both ends means what? L by 2. So means what? 4 pi square EI L square. So what is P2 by P1? What is P2 by P1? Tell me. Very straightforward question. What is P2 by P1? Tell me. What is the answer to this? What is P2 by P1? Straightforward. You see, we have revised almost all the concepts. Almost all the concepts I have revised. What's the answer here? P2 by P1. Tell me. 16 or 32? 16. Yeah, 16. 16 you will get, right? You will get 16D. Okay. Understood this question? From basics formula they are going to ask these questions. From basic formula. If you know the basic formula, you can easily answer. 53 question. The Rankine load is given. We have to find out Rankine load if the crushing load and Euler buckling load both are given 1. So what is your Rankine load? Rankine load is equal to the 1 by buckling load plus 1 by crushing load. So this is 1 by buckling load, both are 1. So this is 1 plus 1, 2. So I can say the Rankine load will be how much? 1 by 2, that is how much? Your 0.5 kilonewton. Very straight formula. Just here you should remember this formula, right? Only this formula is required. That 1 by Rankine load is what? Equal to 1 by the buckling load divided by plus what? 1 by crushing load. Next question, 54th question. Sum on the deflection portion also, some deflection portion. So in this, we'll come to this question later. Okay, we'll come to this question later. Answer me this first. The maximum deflection of a cantilever beam when we have a concentrated load acting on the ends. Suppose this is P and this is L. What's the formula? What's the formula? See, all the standard formula of deflection, please revise that. Okay, for our examination always standard formula. They will ask you from standard formula only. Don't go after so much of heavy studies and you forget the standard formula. Standard formulas of deflection. I'll conduct a session, separate session for deflection also. Don't worry. I'll conduct a separate session, but my suggestion will be what? Use this. Okay, do this. So what is that? PL cube by 3EI. PL cube by 3EI. Okay, A. Now, what is the standard formula again? Slope at the support of a simply support beam with a central load. What is the answer to this? What is the answer to this? What's the answer to this? Question number 57. A. Yes. WL square by 16 EI. This slope is what? This theta is what? This is WL square by 16 EI. Yes. And this central deflection is how much? It is WL cube by 48 EI. Yes, remember all standard ones. So there is given, you see, we have to find out a slope at the end of a simply support beam of span 2 meter, and this is the load. Okay, so we have a UDL acting. When you have a UDL acting and we are asked the slope, what is the slope? What is the slope here for UDL? The UDL slope is WL cube by what? 24 EI. Yes. See, for the point load it is WL square by 16 EI. Yes. And for this is WL cube by 24 EI. Now just put this value. W is given 5. Length is given how much? 2. So 2 cube will be 8 divided by what? 24 EI. This is 3. So 5 by 3 EI. Straightforward question, you see, from the formulas. All the standard formulas should remember. Okay. 59th question. You see, it's a lengthy question. Is given a rolled steel joist, means a beam actually. Okay, is simply supported at its end, carries a uniformly distributed load with maximum deflection of this much and slope of this much. The length of the joist actually means what? The beam is asked. Now when there is, simply support and UDL, okay, you see, this was the slope, and what is the central deflection? The central deflection is 5 by 384 WL4 by EI, right? Yes. Now if you take the ratio of the central deflection, if you take the ratio of this central deflection and the slope, how much you get? Yes, you see this EI get cancelled, W get cancelled, this L to the power 4 actually. Yes, this L cube I get a L here. Yes, and this 24 goes up, I get what? 120 by 384 L, right? This is the ratio of the deflection by slope, right? Yes or no? This is the ratio of deflection and slope. Yes, and this is given how much? The deflection is given what? 10 mm, and the slope is given how much? 0.002 at the ends, and this is equal to what? 120 by 384 what? L. So from here I can find out L. L will be coming in mm, right? Because you see this 10 is in mm. So I want to find in meter. What I will do? I will divide by 1000, or I multiply 10 to the power 3 in the denominator. So this becomes what? 10 by 2, right? 10 by 2, and this is 120 by 384. So now I'll get the answer in what? Meter. So this I can say is 5. Okay, so this again became what? 24. So L is how much? 16 meter you're getting? Yes, getting how much? 16 meter. Again you can see that this question was little complicated. But you were able to solve it properly because you know the formula. Okay, next question. This gives me what? What is this? EI, the triple derivative of y deflection with respect to x. What does this give me? Tell me. What is this? Tell me. Let us see. Moment? No, this doesn't give me moment. You see, this gives me moment, right? EI double derivative of y with respect to x is what? This is bending moment, right? When you take the differentiation of this, you get this, and this is nothing but the shear force, so it gives shear. It's a good question, right? Little tricky, but again this can be asked in the examination. Now coming back to those two questions which I left, okay, these two questions which I left, so this is your homework, okay. So these two are homework. Please solve them and write in the comment section. This question number 54 is your homework number 1, okay, and then the question number 2, the good questions, is homework number 2, okay, homework number 2. Okay, this is what? Question number 55. So 54 and 55, okay, 54 and 55 will be your homeworks, okay, very nice, okay. Now I have conducted many classes for your HPCL and HPCL examinations, and also TSPSC, and for other public sector commission examination, okay. So I have a list of that, okay, of all my lectures for the public service commission examination, right? They're also available in the playlist, but if you want it separately, you can just WhatsApp me, okay, WhatsApp me or send me just ask me in my, I don't have a Telegram group, so you can send me message on my number, Okay, I will give you that I will give the link to that list. Okay, and there you can access what? You can access all the lectures. I have taken such practice sessions for almost many subjects like surveying, geotech and all, and obviously we'll be taking more also in the future. Okay, for Telangana State Public Service Commission examination. Okay, but you can refer to those videos also. So if you want to attend those sessions, okay, so please send me this on this. Okay, okay, understood. So was this session helpful for your examinations? Those who are appearing for TSPSC, and are your all concepts revised for strength of material? Are you feeling and other students also who are appearing for other examination, they would have also felt that they have covered everything, right? Yes. So I request to attend such sessions and also to attend the other lectures which I have taken on YouTube. They are also available. Please attend. And another thing, you see that I have maintained a fine balance, that I didn't enter too much into the questions, because the questions won't be very lengthy, but yes, there will be variety in the questions. You cannot leave any portion. I cannot say that you leave this portion, that portion, because they will ask you basics from all the portions. You have to cover like this. This is the way you have to revise. Okay, so today at 5 p.m. we will have our formula memory test by Joshit sir. So that will also help in your state service examination, because that formula is also asked. Yes, so please attend this. And at 10:45 today, so Richa ma'am will be taking the most expected questions for what? Environmental engineering also. Okay, so you see so many sessions are being conducted, so please keep attending, and if you want that list and also please message me, I will give you the list. Okay, thank you very much, it was wonderful. Okay, so tomorrow I have planned 40 objectives from on cement. Okay, from building material only on cement. Concrete I will conduct another session. The 40 objectives on cement, that will be helpful for all the examinations, TSPSC, UPPSC, MPPSC, GATE, SSC, JE, ESE. Yes, so tomorrow we will have 40 objectives on this. That also will be at 10:30 a.m. So I request all of you to be available at 10:30 a.m. The link will be available soon. Okay, smart list. So you send me I will give you the list. Okay, don't worry. You send me a message, I will give you the list. Okay, I am maintaining another list also. I will give you the list. Okay, and that smart list also will update in some days. Okay, some lot of management has happened, because 2 channels have been separated. So things has to be sorted. So we will sort that. We are doing on the path. So, but I have made my own list. So you can also send me request. Okay, so 10:30 a.m. tomorrow. So please attend this session. Here also we'll revise all the important concepts related to what? Cement. Okay. Then thank you very much. Wonderful interacting with all of you. Hope you enjoyed this session. Okay. And please solve the 2 homeworks and write the answer in the comment section. And if you liked the session, please subscribe. Okay. Like the video. Don't forget to like the video. And also, whatever you want to feel, you felt good, or whatever is your comments, genuine comments, you can mention in the comment section. Thank you very much. Bye. See you tomorrow at 10:30 a.m. with this session. Okay, this is tomorrow, this is today. Madam is taking today, and tomorrow I will take this session. We will do one by one plus. Okay, complete these things one by one we'll do. Okay, then thank you very much. Bye.